busy, so nothing to do. But we're obviously in a new location because you all made it here. And we have a little announcements for the group. One, do you like the new building? Would you like to come work in this building? If so, it was just hiring some software engineers. Or the 3 people that don't work here. If you'd like more information, definitely let me know. I can give you all the info that you have. The second is someone from the Pensacola Chamber called me today, Kelly, somebody. They're doing some kind of startup weekend on March 28th through the 30th.
Is Kelly Reeser?
Yes.
Very nice, very sharp lady, yes.
Just made it.
Hello. Hey,
sweet. Perhaps I should introduce myself. My name is Brian. I'm the president of the user group. Our vice president is somewhat in flux at the moment, although one of our members may become the vice president on those sources. Anyway, Kelly sent this over for the startup weekend. It's kind of a think tank kind of thing where you can come in with your idea and talk about it. There's a flyer if you'd like more information. The final thing that I wanted to talk about was the South Florida Day of .NET is a all-day conference in Mobile on March 29th. So you'll have to choose as to whether or not you want to go to this.
Alabama.
South Alabama, thank you. South Alabama, because it's in Mobile. It's a day of .NET, but they're also doing a Windows Azure like boot camp kind of thing the same day. A number of us at BitWizards have put in to be speakers at that, and I know there's some Microsoft MVPs and stuff that will be there, so there should be a lot of real good information. So if you have any questions, let me know. And the final thing is, Matt, could you go to the my RDP?
Oh, I just closed it. I'm sorry.
That's okay. I'll show it later. I'll show you later. Don't worry about it. It's something else. So without further ado, we have quite the hiatus, but it's well worth the wait because we have Matthew Perry Hill. Now, I've been doing development myself for about 15 years, a long time. In that time, I've managed to destroy a number of SQL databases. Most importantly is when you want to delete a stored procedure, and it's delete dependencies, because that will find everywhere that stored procedure is connected to and delete everything, which is awesome. But Matt is one of the most knowledgeable SQL guys I've ever known. And he has phenomenal coding practices. He's very diligent, he's very detailed. And he has graciously offered to present tonight on SQL Server best practices, which I think applies to just about every developer. Is this SQL Server specific, or is it SQL Server specific?
2000 through 2012.
Okay, so without further ado, here's Matthew Perry Hill.
Thank you, Brian. Thank you all for coming. So let's get right into it. We're going to be talking about SQL Server development best practices. I did. Good to go. So I'm a senior software engineer here at BitWizards. Been here for a little over 6 years now, and been doing SQL Server for about that same amount of time. I've worked on 2000 through 2012, all TP only and no data warehousing. And I guess what got me interested in
What is
Brian,
OLTP?
Online transaction processing. DW is data warehousing. Excellent question. And if you have questions, feel free to interrupt me at any time. I'm sorry, this is my first time presenting, so I'm a little nervous, but hopefully that'll disappear within the first 5 minutes.
We'll do 10 minutes.
So I've always been hooked on performance tuning. I started out doing graphics coding and really loved taking a piece of code and making it run as fast as possible. And so SQL Server was really a natural fit for me because there's so many opportunities to do performance tuning. And so it was a really natural fit. So the question is, SQL Server best practices, why? Well, a lot of people, if you read blogs, people tell you, yeah, it depends. A lot of things in SQL Server, there are trade-offs, pros and cons of decisions that you make. And you want to make good decisions because you're going to have to live with them. So best practices can help you to cover the majority of cases correctly. In other words, following them can help to reduce the number of bad decisions you have to live with. Now, there may be cases where you don't want to follow your own best practices. There may be good reasons why you don't. But like I said, because you have best practices, it'll force you to think about it and to know why you're breaking those rules. And those one-offs may themselves become best practices. So what are we going to talk about? Well, there's going to be lots of do's and don'ts. And there'll be some, hopefully, that you'll never do, or hopefully some you've never done, but hopefully some you'll never do. And there'll be some practical hands-on things, some things that I kind of think that developers should know how to do, but the knowledge just doesn't seem to be out there. A lot of people I've talked to in SQL Server community think that these things should be things that developers should know how to do, but maybe the thought in the past has been, okay, a DBA should know how to do this, but really they're not that hard, and you'll see that they're not that hard, and so, hopefully we'll all learn how to do them. And there'll be funny pictures too, hopefully. And here's my first one. I went crazy with the clip art, so most people know that my wife and I love turtles and tortoises, and so here's my first one. We're gonna try to get SQL Server developers to come out of their shells and see there's more to SQL Server than just creating tables and writing stored procedures. So there's my first clip art. Lots more to come. Okay, so let's get right into it. We didn't start the fire, or did we? Well, so what do I mean by this? Well, I wanted to start with some definitions. What is a DBA and what is a DBD? Well, database administrator and database developer, right? And I like to use this metaphor. I got this from somebody else to describe DBAs. They're like firefighters, really. They put out the fires in your databases and hopefully help to prevent them from happening in the first place. And I kind of did this tongue-in-cheek a little bit. Developers are often the people who start the fires in your databases, and hopefully that's not you. Now, in many organizations, developers may wear one or both hats, so maybe we did start the fire after all. But hopefully we can put it out too. That would be good, right? So what's the problem and what's the solution? Well, the reality is that a lot of SQL Server developers don't want to be DBAs unless they need to be a DBA for a moment to solve a specific problem. So the problem is that the DBA seems to be missing in a lot of organizations, or else the distinction doesn't exist. In other words, people just want you to solve the business problems regardless of your job title. So what's the answer? Well, you can either train or hire a DBA, or if your developers are supposed to wear both hats, then get them to really start wearing both hats, right? So maybe some things that used to be thought of as DBA-only kind of tasks, developers can learn and do as part of the development process, and it'll make them better developers. And hopefully they won't start as many database fires. There's nothing magical about being a DBA. We have some rules for success here at BitWizards. Rule number 5 is be thorough. That's Vince Mayfield's rules for success. Remember, genius is nothing but continued attention. So it's something that anybody can do. It just takes time and effort. So let's get into a very fundamental topic in SQL Server, clustered indexes versus heaps. Well, what is a clustered index? It determines the physical order of data in a table. In fact, it's so fundamental to the table, you can say that a table is a clustered index or it is a heap. So it's like a clustered index is like a phone directory that arranges data by the last name, right? It can comprise multiple columns, like a phone directory is organized by last name and first name. Now, because the rows can only be sorted one way, there can only be one clustered index per table. That make sense? Now, a heap is a table with no clustered index, so the data is in no particular order. Well, welcome to the great debate, because the first question you're going to ask yourself is, well, do I want to make tables that are with a clustered index, or do I want to make heap tables? Well, according to a well-known Microsoft white paper, clustered indexes perform better than heaps in the majority of cases. And the direct quote is, the performance benefits far outweigh the negatives. However, not everyone agrees with that, and it's actually one of the most contentiously debated issues in some circles in the SQL Server community. Now, I'm not going to get into debate because I'm not that brave. Even MVPs steer clear of this debate because it's pretty intense. So I'm just going to assume you're using clustered indexes and not heaps.
Are you going to go into more detail on what those are? Because I'm curious, what are some of the negative, I mean, when you hear that basic idea that you have a clustered index, you have some order, and if it's the primary thing, you probably gain performance. What negatives would you run across, and how would a heap, no order whatsoever, be of any benefit?
Well, that's why I think in part the white paper said that, the Microsoft white paper said they perform better in most cases. Some people that argue for heaps, they have various arguments for it, and they get pretty technical, the debates over it. I personally use clustered indexes all the time. I never use heaps.
I always have too, and that's why I don't even know why. I've always just clustered indexes, and I have no idea why I would ever want to use a heap.
Right, that's an excellent question, because some blogs I've read, people who argue for heaps, they say that clustered indexes don't fit certain applications very well. Like cases where you have like billions or trillions or quadrillions of records in a table may not work well with a clustered index, because as we're going to see, you can run out of key values. If you use like an integer or a big int for your clustering key, you could theoretically run out of values. And so that's one reason why people will say, now you could still, even if you use a GUID or something else, you could still put a clustered index on that, although I wouldn't recommend it. It's really bad for your performance. And we'll talk about that a little bit more. But I think those cases are going to be
the
one-offs.
Something might be, even though there's a heated debate, I thought, well, if you're in this camp, there's X, Y, Z. If you're in this camp, there's Y, Z. I guess it's more nuanced than that.
It is. And I think the cases where you would want to use heaps, or where people would argue for using heaps, are more going to be the exception rather than the norm. That's just my opinion.
Is that what the founding fathers were arguing about?
I guess so. I guess so. That was the best clip art I could find for a debate. So.
Really?
Yeah.
250 years.
The clip art library is pretty limited.
You should see Tabitha. I have no idea where she gets those little pictures for her email.
Yes, they are.
Apparently Matt knows.
Right, so we'll talk about some facts about clustered indexes. They don't have to be unique, so any table can have a clustered index. If it's not unique, then SQL Server will make it unique under the hood by adding a 4-byte integer to the data. Another thing to know is adding a primary key will result in the creation of a unique clustered or non-clustered index on the table, depending on whether a clustered index already exists. So that's just some good things to know about clustered indexes. Another fact that maybe surprises some people is when they migrate databases to SQL Azure, they find that SQL Azure requires all tables have a clustered index. And that probably has to do something with the replication that goes on. I think they make 2 copies of the data, and I believe that is what that's used for. So if you don't have clustered indexes in your database, you're going to have to convert them before you migrate a database to SQL Azure. Just something good to know.
Are you going to cover how to create a clustered index?
No, I'm not.
Okay, so then are you just saying making a primary key on the table? Does that create a clustered index?
It will if there isn't one already there.
Okay, so if the table doesn't have a primary key, you just generate a primary key, does that make a clustered index behind the scene?
Correct. Yep. Good question. Okay, so that leads us to the choice of the clustering key. A lot of people kind of wonder, well, what should be the characteristics of a good clustering key? Well, it should be unique, narrow, and static. I got this from Kimberly Tripp. She kind of summed it up. Why unique? Well, if it's not unique, then SQL Server has to make it unique under the hood. Why narrow? Well, because, and this is kind of critical, every non-clustered index automatically contains a copy of the clustering key value at the leaf level. So if you have a bloated clustered index, you're going to have bloated non-clustered indexes. So that increases your storage, and it would probably also increase your rebuild times. Why static? Well, you don't want the values to change because that would require updating all your non-clustered indexes. So that's why we want unique, narrow, static clustering keys. So the takeaway is that a single column generic key is often a better choice than a natural key. Well, what are some examples? Int or big int using identity property. This is pretty commonplace. And a lot of people, this is a best practice that they use. And it's one that I use, actually, is to use int or big int using identity. If you only use positive values, then you get 2.1 billion for int and 9.2 quintillion key values for big int. And this is, like I said, this is one of those things that people who argue for heaps will say. This is one of the arguments they'll make, is that if you put a cluster key on an int or a big int, you could potentially run out of values, right? So what are you going to do in that case? Well, some people, you'll either know how much data is going to be in the table. You may or may not. It helps if you know ahead of time because you want to make sure you're not going to run out of values, right? I mean, if you run out of values, your inserts are going to fail. So that could mean taking an app down, essentially. So it helps to know how much data you need to handle in the table when you build it. Some people will take the approach, though, because they want to play it safe, of doing something like this. What about unique identifier, or GUID as a clustering key? Well, the problems with that are that the new ID, which is used to populate, is, in other words, supply the identity values for a GUID column, it's random. So it results in index fragmentation because of page splits. You can have a page split anywhere. Brian?
Back in your previous slide, can you convert an int to a big int? Do you know?
You can.
If you try to run out of room, could you convert it?
You could. You could actually do that, and I've seen cases where that's been done. It probably would require rebuilding the table, but you could actually change the int to a big int, and you could get more space. Now, you have to change your app and your stored procedures accordingly, but you're right. If you run out of space, and I've seen cases where that's happened, you could change it to a big int.
Okay, and 2 slides back. Are you going, if you're going to talk about it, don't worry about it, but explain what a natural key is in case people don't know?
A natural key would be something like social security number or employee ID number, something like that. That's unique, but maybe a character value. Some people even generate their own key values using some other function. And the only problem I see with that approach is that those, if you use that as your clustering key, it can get very large in terms of the storage.
There was a time in the 90s that was really popular using natural. I wanted to do natural key, and then people were so wholly tech war over that because you couldn't get a single natural key, they would actually concatenate the next key. You'd have something like last name with birthday or some craziness like that, which was just silly and caused lots of performance problems with that. I worked at 2 defense contractors where they had DBAs. You must use a natural key. Yeah, as a developer, I would always despise them.
I would too. Okay, so if you do use a GUID, another problem is that you're going to get bloat on your non-clustered indexes because of the fact that every non-cluster is going to point back to that cluster key. So if you have to do it, if you have to do it for some reason, there are alternatives. You can consider using new sequential ID instead of new ID. Basically what it does is I believe under the hood it takes the MAC address of the network adapter and it tags on a unique value to that, but it does it in such a way that the values are always increasing. So remember that page split problem we talked about with new ID, where you get page splits because it's random? Well, new sequential ID will increase in a predictable way, and the records will always be added to the end of the index. So it avoids that page split fragmentation problem. The only problem with that is that new sequential ID is predictable because it's based on the network or the MAC address or NIC adapter address. And so that can present a security risk if a value can be seen by end users because they can know what the next value is going to be. So if you have to use new ID and you can't use new sequential ID, then whatever kind of index you create for your GUID key, you should probably defrag it or rebuild it often because you're going to get tons of fragmentation. There is an alternative though. You can use int or big int for your clustering key and make a non-clustered index on the GUID column. I have done this and it works pretty well, because you get the benefit of an index on the non-clustered. If you need to do a lookup, you're doing a seek as opposed to a scan, and you don't have the downside of using too much storage, and your index rebuild and defrag is going to be better.
How does that work? Because it used to do it as so it's unique.
Mm-hmm.
There must be some reason you didn't want to use that identity big in it. So in your specific example, you said you've done it. What situation forced you to have a GUID, but also allowed you to have an identity?
That's a good question. The situation was that the GUIDs were needed for uniqueness, essentially, because the values that were inserted could come from multiple places. So a lot of times, that's another reason why people choose a GUID. Right, you have disparate data, and they could be coming from different sources, but they're inserted into the same table, so you want to make sure there's not going to be a collision.
And then you after getting this disparate data into the table, that's when you increment to create the identity for that particular column.
Exactly.
Okay, I see that, yeah.
So, Matt.
Yes.
Obviously, we do a lot of Canico development, and I've noticed that a good majority of their tables have both an identity that's an int, and then they also have a GUID column as well. Is there a reason to have both?
There can be, and the case we just discussed with the disparate data is a good example. I worked on basically a report service, and it would take a GUID, and the application would create the GUID, and it would get, that record would be inserted into the table. So there would be an integer ID associated with that, which would be the clustering key, and then the GUID would have a non-clustered index on it. For Canico, I've seen also SharePoint is a well-known one that uses GUIDs, I believe, for the cluster key, and that causes, well, if anybody's done SharePoint, you know that SharePoint is kind of an animal unto itself. If you have a SharePoint server, you kind of put it on a completely different server from any other SQL server, so it's kind of special in that way. So I don't know anything else about SharePoint other than that. I don't know how Canico uses a GUID, but it might have something to do with that, with disparate data coming in from different sources, and it guarantees that you won't have a collision on the GUID, but the benefit is that the app knows that GUID, so it can do a lookup to get information about that record.
Yeah, that's what I've noticed. It's primarily, like if I'm debugging through the API calls, they're using the GUID as opposed to an ID, and they're looking up things.
Exactly. Yep. Any other questions? Okay. Moving on. Not yet, right? So now we're going. Courtesy of Microsoft Clip Art. Yeah, I forgot the turtle on this one. Foreign key constraints don't cramp your style. Well, what are the benefits of foreign keys? They help to elucidate relationships between tables. They enforce data integrity. And guess what? The performance can be better. This is something that most people, I don't think, either know about or don't think about or don't care about or I don't know what. But the optimizer doesn't have to work as hard. Grant Fritchie, he wrote a blog article about this, about how if you have trusted foreign key constraints, you get better performance because SQL Server trusts that constraint. It doesn't have to go and look at that foreign key table to see if the value you're passing in is legit. It trusts it. So it basically reduces the amount of I/O for your queries. There is a write penalty with foreign key constraints because if you're updating a record or inserting a record, it has to go and say, oh, the state of Florida. Okay, that's in another table. So I have to go look that up. There is a write penalty to that because it has to check the value to see if it's legitimate, if it's actually in the parent table. So, but that's kind of mitigated because really, if you think about it, and if you look at what your workload is doing, it's probably more read intensive than write intensive. Most people probably don't look at this. You know, it's not something we think about a lot. But even with an OLTP system, it's probably more read intensive than it is write intensive. So that can be mitigated somewhat. I have seen cases where if you have a lot of foreign keys on a table, you can sometimes see locking occurring if there's a lot of write contention on that table. And I guess the only way that you could get around that is maybe doing selective updates to avoid updating the foreign key columns if you don't need to update them. I've never tried that, but that would be one thought. Another thing is you could probably look at partitioning the table. Another thought. Let's talk about some options for foreign keys. They can be fully or partially checked. Fully checked is a default. Partial checking is possible with the no check option. If they're partially checked, the constraint will only be enforced on inserts and updates. So if you have a table with dirty data, you can actually put a foreign key on it and create the foreign key with no check, and it will keep the data pure going forward, but you won't have to clean the existing data. This is great for cases where you have like maybe a table that has invalid social security numbers in it. You create your foreign key constraint or your check constraint. This would be more applicable to check constraints because this assumes you're kind of doing some sort of validation logic on it. But if you had a table and you wanted to put a foreign key on it and you had bad data in it, you could use the no check option to keep data pure going forward and then go back later on and clean it up. The only downside of that is that the constraint won't be trusted by the optimizer, so you lose the performance benefits. Questions?
Well, I'll add another problem with that, and that's that often developers assume let's enforced by the database. You know, by enforcing under UI, and it'll blow up.
That's right.
So one reason not to is, you know, if you need defense in depth, if you're checking some kind of, you know, this is a required field. You say, oh, the database says it's required field, so I can assume it's always there. It might be good still in your code to say, is it there? Before you try and display it and blow up your front-end application.
That's right, because really dirty data, I think, is a big problem. And the more you can do on both sides of it, on the database and the app side, to keep it clean, the better off you're going to be, the less problems you're going to have. You know, dirty data, it just garbage in, garbage out. You know, what more do you have to say about that? So, foreign key constraints help keep your data clean. Okay, recommendations. Are your foreign keys enabled and trusted? How do you know? You may not, right? Unless you query sys foreign keys, you don't know. So there is a way to query that. You just query sys foreign keys, and there's certain columns you can look at in your where clause to figure out whether they've been disabled. A lot of times I find that when people are doing ETL, extract, transform, load data into tables, they'll disable foreign key constraints to boost their load times, but then they won't turn them back on when they're done. So you lose the performance benefits of having a foreign key there. So another, yes, exactly. Exactly. So there's actually numbers of downsides to that. Another thing to think about too is to not abuse cascading foreign keys. I have seen this in real life, and it is extremely painful. It's probably one of the, I don't know, it's probably one of the biggest things that leads people restoring databases that I've seen anyway, where people, basically what they do is they make tables that have cascading foreign keys that go all the way down. Instead of restricting it to 1 or 2 levels, it goes all the way down. So you delete the record from the parent row, what happens? From the parent table, it cascades down and deletes everything. So essentially you get a domino effect, and you can lose tons of data that way. Another thing about cascading foreign keys is that they can increase your locking contention, because under the hood, guess what it's doing? It's taking a serializable lock while it's doing the delete or update or whatever you're doing. So something to think about. If you're getting deadlocks, that could be a reason for it. You're getting serializable locks under the hood. Questions? Check constraints help keep your data clean. So again, we get enforced data integrity. I love check constraints. I can't say enough good things about them. They're pretty smart too. SQL Server knows which columns are involved in the update and will evaluate the check constraint when the data changes. Like foreign keys, they can be fully or partially checked, and it's one example of where scalar functions don't necessarily kill your performance. I love this for things like SSN validation, because you can define a scalar function that performs validation against an SSN, determine whether it's valid according to the Social Security rules, and you can get those up on Social Security website. But you create a check constraint and point it to your scalar function that validates that SSN, and if a record's not valid, if it has an invalid social, it just kicks it out. I mean, it will keep your data clean. And that's, how often do you update your SSN? You insert a record, right, with an SSN in it, or an employee number or whatever, identifier you're using. You have that check constraint on there. Chances are it's not going to change, Now, if it were data that changed all the time, then you could have a problem because you're hitting that scalar function over and over again. But for the most part, if you use this judiciously, it can really help to keep your data clean, and it won't kill your performance. And again, for ETL, you can disable constraints at the start of the ETL process and re-enable them at the end. That'll boost your load time. And again, the same goes for foreign keys. Questions? I hit the space bar already. Oops. So now we're going to talk about non-clustered indexes. Well, what are the benefits? They can drastically improve your read performance by reducing I/O. And that's really the goal in SQL Server. I/O is king. If you can reduce I/O, chances are you've improved performance. So indexes, non-clustered indexes can really help you to reduce I/O because SQL Server can use the index. It can do a seek as opposed to a scan. It may be able to look up the data it needs from the index rather than having to hit the table directly. So it can also improve your query plans. And if you look at query plans and you see a bad query plan, you add an index and you see a completely different query plan that looks so much better when you're done, you know what I'm talking about, because indexes can make that kind of difference, a dramatic difference in a query plan where you go from having warnings temp DB spills. You can go from basically something really ugly to something that's beautiful and performs very well. Another benefit is that an index can help reduce blocking on a table. If you cover your query with an index, it's not even hitting the table, so you essentially reduce locking. So costs and risks. What are the risks with non-clustered indexes? Well, there is a write penalty, because every time you write to a table, it's going to involve an index update. Assuming that the data you're modifying affects that index, there's going to be an update to the index. So there's a write penalty involved. Another risk is you could have unused indexes. And how would you know? And this is one of those things I think that developers should know how to do, to see whether, first of all, to be able to create non-clustered indexes, and then to see whether they're being used, to know how to look for duplicates. I think that could be something that's within the reach of most developers, really. And that could be part of the development process. So that instead of creating an application, pushing it out to production, and then finding out there's a whole bunch of missing indexes, you could do that as part of your development process, and you end up with a better product and not have to do as much maintenance down the road. So duplicate indexes should be checked for periodically and eliminated to make sure your write performance is optimal. Well, here's some recommendations. Starting in SQL Server 2008, they introduced missing index warnings in execution plans and DMVs, which are dynamic management views that tell you when indexes are missing. And I love these dynamic management views because it's kind of like you pinch somebody, they say, ouch, right? Well, SQL Server does the same thing. You run a query, SQL Server says, ouch, that query hurt. I could have used this index. It would have made it a lot faster. So that's what the missing index dynamic management views do for you. They give you a way to see which indexes you need to create on your tables. And the beauty of it is that it's based on queries that are already running on your system. Has anybody ever used Database Tuning Advisor, DTA? What's the problem with DTA?
I don't know what I'm doing.
I'll be honest. I'll admit I've never used it. And the reason why I've never used it is because you have to give it a workload. Why am I going to want to take the trouble of creating a workload for DTA, right? So the thing, the DMVs, the beauty of that is that it's already running based on queries you're running in that system. So you're going to know which indexes you need to create, and we'll see that in the demo. So another recommendation is you want to keep your non-clustered indexes as narrow as possible. Why? Because of that write penalty. Because every time you write, okay, if that column that you're writing to is involved in an index, it's going to have to update that index. Now, if an index has multiple key columns, not included columns, you want to order them by the highest level of selectivity first. What do I mean by that? Well, could you imagine a phone book that was arranged by first name, last name, rather than last name, first name? Would that be fun to use? Probably not. Yeah, Brian, that's true. Your name is pretty unique. You're kind of a counterexample. My name, Matt, would be terrible because you look up Matt and then you have like a million different possibilities. Well, SQL Server works the same way because what you want is you want your first column in your index or your however many you've got. You want them ordered in order of high selectivity. So you want last name, first name as opposed to first name, last name. You're essentially getting to your results faster. So that's something to keep in mind when you're creating non-clustered indexes.
Real quick, Matt, what is a phone book?
What is a phone book? Yes, that is an ancient device. I can tell you about it because I'm old enough, but I can't tell you when the last time was I used one.
That's funny right now, but in TV, that would be a serious question.
Yes, yes.
It's still funny now.
Okay, so some more recommendations. Keep in mind the costs because your included columns can help cover a query, but they increase your index size and maintenance overhead. And one of the things you'll see when we look at these DMVs is that sometimes the included columns list is like 10 miles long. You know that's not an index you want to create. Pretty much. I mean, I'm going to go out on a limb and say, if you've got an included column list that's 10 miles long, you don't want to create that index because the write penalty is going to be tremendous. So, again, check to see whether your indexes are being used. We'll see that in the demo. And one final point. Very important. Don't ever put the clustering key in a non-clustered index. The DMVs and the warnings, the missing index warnings, will tell you you need to put the clustering key in the non-clustered index. Don't do it. There's no reason to do it. Who can tell me why? Who can tell me why? Because the clustering key is already there. It's already there. Every non-clustered index has a reference back to the clustered index, right?
You said that before, it's always there. Yeah.
It's always there. Exactly.
So
There's
you're putting it in twice.
exactly. So you're just wasting space. Yep, and you're increasing your write penalty potentially. Okay. I've got a side note here on filtered indexes. Is anybody interested in filtered indexes? I might skip this part. It's kind of obscure. They were introduced in SQL Server 2008. They only apply to non-clustered indexes, and it basically allows you to filter the definition of an index so it only applies to a subset of rows in the table. Okay, maybe we'll cover it fast. How's that sound? It's supposed to improve your query performance and plan quality, reduce your index maintenance costs, and reduce index storage costs. However, what they don't tell you is that it may not be useful for improving performance of queries because the index may or may not be used in a parameterized query. I'd love to illustrate that with an example, but I don't have one. Basically, if you pass in a parameter and you have your query, and your query is looking at that parameterized data, which is even part of your definition. Like say you have a bit column, and you have, say it's an imported column, and you pass in a bit with a value, 1 or 0, right? And you run it through that query where you're saying where imported equals your parameter. Well, guess what? The filtered index may not be used in that case because SQL Server doesn't know whether you're meeting the definition of the filtered index. So essentially what happens is the optimizer will look at it and say, I can't use this. I can't use this index because this query is parameterized. So essentially what you're doing is you're creating more overhead for the optimizer because it has to look at the filtered index to see if it applies. It may determine that it doesn't apply because your query is parameterized. And forced parameterization makes the problem worse. And I'm actually going to show you what this looks like in an execution plan because I saved the sample. Let's see. This is kind of an obscure topic, but I wanted to mention it because it's something that was introduced in SQL Server 2008, and I don't think that, where is it? Here we go. This is what it looks like. This is from a query plan from a database I've got at home. Okay, don't need that. This is essentially what the warning looks like. So they added a warning in SQL Server 2008 that's, oops, got rid of it, that tells you about unmatched indexes. And it gives you this warning, says unmatched index is true. So basically what it did was I had a filtered index on this table, and it says, hey, I can't use this thing because it doesn't, this query is parameterized. So I have no way of knowing whether that filtered index meets the definition of the filtered index.
You can't do that at runtime with the idea it needs to use it before.
Because your data may be outside the scope of the filtered index. If your data that you're looking at by specifying that parameter is outside the scope of the filtered index, SQL Server's like, I don't know what to do with this. Yeah. I can't use this index. So, that's one of those cases where I think it's good to know about. I still think there may be some value in filtered indexes, but I selected the wrong thing. But I think that there's a little bit too much maybe marketing hype over them, and I just kind of wanted to bring that out as kind of a gotcha.
Okay, you're trying to get improved performance, you actually decrease performance.
Exactly, and that's the takeaway. That warning may not be a problem, and sometimes it can be ignored, but I think that's something that developers should know about. And this is a part of the lessons learned. The thought of saving space with a filtered index may not be worth the potential downsides if your goal is to improve performance. They may still be useful in cases where you want to enforce uniqueness on a subset of records. And I'll tell you a good example. You might have a column that's nullable in your table, and you might want to say, okay, when that column's populated, I want it to be unique. Well, before 2008, SQL Server 2008, you couldn't do that. There was no way to do that. But filtered indexes give you a way to do that. When you create the index, you make it unique. You declare it as unique, and you say in your where clause where this column is not null. So essentially, the uniqueness only applies to the subset of rows that are populated. So the takeaway is that if you use filtered indexes, you use them judiciously and confirm they're actually doing what you intended them for, because they may not. All right, now we're going to do something really hands-on. I kind of regret having doing that filtered indexes thing. I don't know that anybody really. That was kind of.
Well, it's good. I did not. That's one thing you hit on that I had no clue of. I did not know what that was you brought up. So it's nice to know what exists at least at that level.
Okay. Well, we're going to do a quick demo on missing indexes, and let's talk about what we're going to learn here. Let's see. Okay, so we're going to see how to use the missing index DMVs that are built into SQL Server 2008. We're going to kind of run that through a sanity check to make wise decisions about creating missing indexes. And then we're going to show how to confirm whether those indexes are actually being used. This is one of the things that I think developers should know how to do. Just hands down, I think this is one of those items that most developers probably don't know how to do. Who here knows how to create missing indexes? Just anybody mess with that? Just kind of as a sampling. Okay.
I've created indexes to that, but I've never actually looked at the missing ones, I guess. I've done a query plan and then created them. That's not the same thing. You're saying missing indexes by using the query to find out what it needs and then adding to it, right?
Exactly. Yeah. And you can do that either through the execution plan, which SQL Server 2008 will warn you about. I don't know if I'll show that part, but I will show the DMV side where it actually lays out which indexes are missing. So that's what we're going to do. So let's head over to AdventureWorks, and we're going to run our missing indexes demo script. So this is just pulling some records from sales order detail and sales order header in AdventureWorks using different where clauses. So we're going to run that once, and then what we're going to do is we're going to bring up a query that looks at those DMVs and checks to see if there's any missing indexes. Well, lo and behold, there are some. And let me tell you a little bit about this. This is kind of a rig query, but this is what it's pulling from. This is the underlying DMV, and it starts out with these group stats, and you join out to the index groups, and then you get the missing index details, and that essentially gives you the indexes that are missing. I filtered it down in this database, but you could view everything on an entire server this way.
Are these in like the master database where these tables are, and is it?
This is a dynamic management view.
Okay. So it's dynamically, every time you run that query, it figures out what this information is?
Exactly. And the beauty of this, what I love about this, is again, remember I told you this is based on data that's running in your system. So remember that ouch factor I told you about? That you pinch SQL Server and it says ouch? Well, guess what? Every time I run this, SQL Server is going to be feeling the pain. So I go back to here and I rerun this. Watch what happens to these numbers. Ouch, that hurt more. That query hurt more because you're running it over and over again. The beauty of this is, and this is computed based on information that's available in the dynamic management view, but the beauty of it is that you can focus on your worst offenders. You can sort this descending and say, oh, these are the indexes I need in my database the most.
Across the entire database, not even on a table by table. I mean, this is like a DVA function. On most windows, you're in the entire application and say, what's costing me the most?
Right. I mean, I filter this down to one database, but if you don't filter it, it gives you everything on the server. Yeah. Everything that's running on the server.
You may be taking a smaller hit on a particular table, but you're hitting that table 1,000 times more.
Right.
And so you actually, yeah.
So what it tells you, and this is where you kind of, it tells you the statement, and the statement is actually the table that was involved. So it gives you the database, the schema, and the table name. The equality columns and inequality columns are the key columns of your index, okay? So these would be the ones that would be defined in your key. As you can see here, we've got line total, unit price amount, and tax amount. Well, it just so happens, if you look at these queries, what are they querying on? Unit price discount, line total, and tax amount, right? So we see that reflected here in our equality columns. Now, it also wants these included columns in the indexes, in the case of the first two. So it basically tells us how to create the index.
Now, in the first two, it actually tells you to do the identity column, but if you still exclude that because it's included already. So that's what we talked about going to the. If
you saw the clustering key in here, you would need to ignore it. Yep.
And isn't that what that is?
I don't know what it is for that table sales order. I actually don't know this database very well, which is kind of embarrassing, but you're probably right that is the clustering key. I don't know for sure. Let's find out. It's actually a compound key. So that's a little bit more complicated situation there. They have a compound clustering key. They have it's probably dependent on another table, is what my guess is. But yeah, that's the clustering key. So in this case, I probably would add it. I personally probably wouldn't.
It's a compound key, so you want that one by itself.
Exactly. And that will help cover the query. So
That looked like it was example. See, here's an example.
yeah, and actually I wish I had examples that were more complicated, because when I look in production in most databases I work with, the included columns list is usually 10 miles long. And those are the indexes that I just completely ignore, because I would never want to deal with the write penalty of creating an index like that. I mean, you might do that for data warehousing, because your data is for the most part going to be read-only. It's not going to be written to. And in that case, you might want to create an index like that covers your query. But in an OLTP system, I would never do it, because your write performance penalty is going to be so high of maintaining that index. So what we can do is we can actually create these indexes. I have scripted them ahead of time, and we can see the result of creating them. Oops. So we're going to go ahead and create them. I've scripted them ahead of time, but as you can see, the definition is basically what we saw in the DMV. It's just that I've done the syntax ahead of time. So I'm going to execute that. That creates the indexes. And I'm going to run this again to show that, guess what? They're no longer missing. So this is running real time. I mean, this is awesome. You don't have to run DTA and give it a workload. You get this data whenever you want to look at it. You could even report on it and have it send this information to you, I mean, the thing is about systems we build is when you start out in development, a lot of times we don't load them up with a lot of data, I mean, not all developers do that. Some developers do. They'll load up the system with a bunch of data and they'll look for cases where their indexes are missing, but how often does it happen that nobody really loads the table up with data, just pushes it out? Well, you know that you're going to benefit from indexes more when you have more records. So if you did push something out in production, this is one way basically to look at it. Or if you're in development, you can load your tables up with data, run your queries, and say, oh, here's my missing indexes. And so you're not having to think too hard about what's missing. SQL Server is doing the work for you behind the scenes and telling you, here's what you need to do. I mean, what could be better than that? And so now if we run these queries, if we looked at the execution plan, which we didn't look at before, we would probably see that we're doing seeks on these indexes now. And I should have probably shown that ahead of time, but you see that they're all seeks. Whereas if I get rid of them and run it, what do we see? Well, here's the other side of it. I didn't show this, but this is good. We're looking at it. Notice that we're getting totally different plans. We're getting, yep, and we're getting more rows involved too, because notice it's operating on 121,317 rows, as opposed to hitting an index, hitting those missing indexes. And so if you looked at I/O, if I set statistics I/O on and looked at it, you'd see a huge reduction in your I/O as well. And here's the example too. I didn't show this, but this is one way to see your missing indexes as well. If you turn on your execution plan, your actual execution plan up here, and you run the query, it's going to output this beautiful visual format here for you, and it's going to tell you about missing indexes. So this is another way to do it. If you don't want to run the DMV query, just click this button, hit execute, look at the execution plan, and say, oh, I've got a missing index. But remember, use your brain. Okay, if it's telling you to include 15 columns in that index, think twice, because your write penalty is going to be tremendous. Another beautiful thing about this is that it actually gives you this missing index details thing. You right click on it and hit it, and guess what it gives you? Yeah, it gives you the index create definition. So all you have to do is uncomment this, run it, and you're good to go.
Man, you guys got some good. I used to have walls.
So yeah, we've got some cool toys now. Microsoft has done a really good job at that, I have to say. Okay, so questions?
I
I'd just like to punctuate that. I mean, here at Big Wizards, we build business applications. Almost everything we build is based around some kind of data, some kind of user data. And the performance, when we have those issues, this is the number one place is that communication back and forth. It's a huge benefit. So thanks for this.
My pleasure. Any other questions on the missing indexes demo? Yeah, and if anybody wants these queries, like the missing index query, just let me know. I'll be glad to share it. It's a pretty easy query. You can even probably find it online, but
Could you put it with your presentation?
Yeah, I can do that. And I'll give it to you, Brian. I'll just give it to you, and you can have the query files. You can post them right up online. Okay, so.
What you actually can do, man, is you can do all of your queries. You have a bunch of separate queries.
Yep.
Put them in zip file.
Will do. Okay, I think I already dropped my indexes, so I'm leaving AdventureWorks in a good state. So.
Matt, do you find that you have to? Is this an ongoing process of looking at indexes, is it a never-ending thing with the database?
Yeah, to some extent I would say it is, because really, in reality, when you do development, you're probably not going to load the table up with tons of data, and you're not going to foresee all the patterns that you're going to need to. There are some cases where I create non-clustered indexes just automatically. I know this table is going to have 10,000 or 100,000 records or more in it. I'm going to create a non-clustered index in certain cases. One case that I would say I do almost all the time is where I have a parent table and a child table, and you have a foreign key from the child pointing back to the parent. If I know that child table is going to have a lot of records in it, or sometimes I just do it automatically, I'll create a non-clustered on the foreign key column, and that will boost your join performance tremendously. That's just something I do, That's one case where I can kind of see doing it automatically. But again, you have to calculate the cost. I mean, if it's a table that has, if you're looking at a state table that's got 50 records in it, you probably wouldn't want to do that in that case. But that's one case where I often do that. Did that answer your question?
Yes. I mean, it sounds like it's an ongoing thing.
It is an ongoing thing. And I think it's something that probably should be ongoing because, like I said, you can't always anticipate stuff like that. And sometimes, developers aren't perfect. They forget to. You forget to look for where you should create your indexes. And so running this on a regular basis, I have done this on numerous projects. Sometimes I've been called in just to do this on certain projects. And what I'm doing now is exactly what I did. And I think it's...
Surya magic, huh?
That's right.
Well, if you want to just call it out like that. You say others as well, I know, but recently, I know we dropped from 6 seconds to 2 seconds, or even 1 second in a lot of cases.
We shaved multiple seconds off of pages.
The 6 seconds is a long period of time to wait. I mean, people think 6 seconds, what is that? Yeah, you sit there and wait every time you click for 6 seconds to see how happy you are.
Especially on web, yeah.
Yeah, it's not tolerable.
So would you say that every table that you make as a developer should always have a primary key, therefore a clustered index on it, and then you go back and look at it from a objective point of view as to which ones have a non-clustered index? I mean, would that be your methodology about one of the things? Pretty
much. I mean, like I said, I would say almost all the tables I make have a clustered index. Sometimes I have cases where with junction tables where I've got just a table that hangs off another table, and all it's got is a reference back to the parent plus a single value, and you can have like multiple values. A lot of times I'll just make that a compound clustering key, and I'm done. And sometimes I might make a non-cluster that hangs off of that. That is kind of a one-off. That's kind of against my best practices because my clustering key is compound, which I don't like to do very much because of the increase in the storage. But I'll sometimes cheat like that because I don't want to maintain the primary key values, And if you recycle IDs, I don't know if anybody in here has done any ID recycling. That can get ugly because you're essentially going to have to take a serializable lock to get the ID, and you can get deadlocks and other problems from that. So,
is there a function? I guess in the small data world when I was writing this kind of stuff, I didn't have a problem. Is there a function to do that, or do you have to write code? I mean,
2012 has a sequence thing that they've created. I haven't messed with it much.
So find your removed IDs and keep back an ID number.
It won't do that, but it will allow you to number, kind of like you do with an identity. And I've even heard some people say that the performance is a little bit better than an identity. I haven't verified that, but I haven't tried it much with sequences. But in terms of getting a value back, I have written code to do that. And like I said, you do have to take a serializable lock because you have to make sure that you've got single-threaded access through there at a time. You know, that's
can't bring the key back and have somebody stick it.
Exactly.
Yeah.
Exactly. And I've done it efficiently. I think I've done it as efficiently as I can, but I wouldn't recommend it for anything that's going to be high write throughput or even high read, because you're going to end up with cases where you get deadlocks.
And developers don't do that, and run off writing some new code or what you roll out.
Right.
If you don't, it brings it back until you send it back again, right?
You're absolutely right. I mean, that could be a landmine waiting for somebody else down the road.
If you brought it and locked it, and then went off and did some other processing. And
Yeah, in other words, somebody who came along afterwards and wrote something else and didn't realize, yeah, I'm running in a serializable lock, that could cause some serious problems. Yeah. Okay. Any other questions on the missing index? Okay, great. Well, I guess we'll move on until pizza comes, because I
It
can.
should be here any minute.
Okay,
So we'll kind of just keep going until it gets here.
sounds good. Okay, so we're going to talk about stored procedures versus ad hoc SQL. Well, stored procedures, what's the benefit? They can be compiled and stored in the plan cache, right? So if you cache a plan, you're going to have faster execution than if you don't have a cache plan. And ad hoc SQL may or may not benefit from plan caching. It depends on the final SQL string that's executed, regardless of how it was created. One thing to consider is forced parameterization turned on. It's not turned on by default. That's a database level option. And like I said, it's not turned on by default, so it's something you would have to turn on. There can be, in some cases, downsides to turning on forced parameterization. Brian.
Force parameterization.
It basically is a setting on database level that SQL Server, if you turn it on, SQL Server will try harder to parameterize queries. SQL Server will automatically parameterize some queries, but some queries it doesn't consider safe for parameterization. And so if it doesn't consider it safe for parameterization, it's going to back off and say, hey, I'm not going to parameterize that. I don't think that's good.
Is that like a serialization of the information you get, or?
It really determines how hard the query processor tries to parameterize your query.
Okay.
And so if you turn it on, it's going to try harder to parameterize the query. Another thing to consider, and this is not really with regard to plan caching, well it is, but it doesn't have quite the same effect. It's a server level configuration option called Optimize for Ad Hoc Workloads. Anyone familiar with that? If you turn that on the server, essentially what it does is every time you execute a query, it will put a stub in the plan cache instead of the full plan. What's the benefit of that? Well, if you have a lot of ad hoc SQL being thrown at your server, it will prevent single-use plans from being cached. So if you have a single SQL string that's very specific to like one record, and you throw that up at SQL, and this option's turned on, it's going to say, well, you know what? You may never execute that again. So I'm going to store a stub of that in the plan cache, but I'm not going to store the whole plan, because guess what? Plan cache memory is limited. So that's the problem with ad hoc SQL, is that if you're running tons of ad hoc SQL, you're creating contention over that plan cache memory. So SQL Server is going to push older plans out, right? And you may end up with a lot of churn on your plan cache. That's bad. It's called plan cache pollution. So if you turn on this option, which is, like I said, it's a server level setting, there's not too many downsides to doing it. I have actually considered doing it in some cases where I have seen servers that are having a lot of ad hoc SQL thrown at them by third-party tools. And basically, it can help to prevent your plan cache from being polluted. Does that make sense? It's kind of an advanced topic, and you kind of almost have to see it in action to appreciate what it does. But that's kind of a short description of how it works. So then, going back to ad hoc SQL, well, was the query auto-parameterized by SQL Server? In general, auto-parameterization only happens with trivial execution plans. So if you think and trust in SQL Server to say, oh yeah, I'm going to throw tons of ad hoc SQL at you, and you're going to parameterize it for me, you're wrong. It's probably not going to do it. And I have seen plan cache pollution in production environments, and it is ugly. You see tons of these ad hoc single-use plans. You can actually query this and look at it. You can actually, see a whole big list of 27,000 of them, or however many are in there at the time you run the query, and it's pretty ugly. And in those cases, you're going to end up with pretty high turnover in your plan cache. And SQL Server has some options. There's a trace flag you can turn on that increases the amount of memory to your plan cache, but it's not really recommended to turn that on. So it's better to not do ad hoc SQL. That's the takeaway. So again, as I said here, there's a very real danger of excessive compilation and plan cache pollution with ad hoc SQL. It's something you want to avoid. It's not something really that I think professional developers should be doing. I really don't. It's just my opinion, especially when it's so easy to write stored procedures. Parameterized stored procedures, it's just kind of a no-brainer. Okay, so recommendations are to use stored procedures and avoid use of ad hoc SQL. Keep your stored procedures simple. CRUD is best. Why? Well, simplicity can help to avoid performance issues like recompilation and failure to generate a fully optimized plan due to timeout in the query optimizer. I don't think I've seen timeout in query optimizer very much, but I've heard it's pretty bad. Let's put it that way. The query optimizer will eventually, it tries as hard as it can, and then essentially what it does, it gives up. It says, I couldn't generate an optimal plan, and it's like the first thing you see on the first operator, like it's on your select operator. You should always look there to see what the optimization level is, and I'll show you that real quick. Brian's got a question. Duffy does.
What's CRUD?
What's what?
What's CRUD?
I believe it stands for create, read, update, delete.
Okay.
And I'll actually show you what this looks like in case you've never seen it. Here we go. Optimization level, trivial. And this occurs on the first operator in your execution plan. So this will tell you how hard SQL Server tried to optimize a plan. If your plan's trivial, it says, okay, it was easy for me to find a plan. But if you see timeout here, yeah, that's a problem. Because it means SQL Server tried to generate an optimal plan and it gave up.
I mean, what would do that? I mean, like using temporary tables, using cursors?
I have never actually seen it, but I've...
Challenge?
It would probably be some pretty ugly code.
It's funny you say that. Somebody who's pretty solid front end and back end developer, when you keep your stored procedures simple and do your processing on your front end, or will you take and go ahead and load that up on, using T-SQL components and, like it says, cursors and temp tables?
I don't recommend it.
Yeah.
I don't. I mean, I think everybody at some point in their SQL development career goes down that road and learns that that's not a good way to do things. That it's better to keep your stored proc simple and put, your
Just
business.
the data you need and let the processing happen.
Yes.
In the business layer, whatever that is.
Yep. And that's really the primary reason. Some people get really into heated discussions about where to put business logic, but I think that on SQL Server side, performance is going to be what dictates not putting your business logic there. Because if you do a lot of if, else, yada, 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 you end up with a mess. You end up with a performance nightmare, essentially is what you get. You get recompilation.
Now, to that point, you have conditional SQL logic in which you have to pull, let's say you have to pull a data set or pull a sequence of records. You need to loop through those records and do some aggregate function or something on them, and then from there do a query against that. Are you saying, well, of course you're saying this because you're a database guy. You say throw that on the application logic. So the application has to open a connection to the database, pull this data, do the processing against it, open another connection, or reuse the same connection, but do another pull against the database to get some other information, and then go forward from there.
You're going to love this. It depends. It depends. No, I agree with you, Brian. I think I agree with you because with what you're saying is that, yes, I think it's probably better to keep your stored proc simple and to put that logic on the code side. However, there can be downsides to that because that increases the chattiness of your application. I've seen cases where you're constantly hitting the database back and forth over and over and over again, and it really becomes a bottleneck. So you have to be judicious with this. Sometimes caching data, making one stored procedure calling caching data, can be a better way to improve your performance, where you're still putting your business logic on your code side, and you're doing things in your code to proactively address bottlenecks. That's an approach I often take, and I find it works pretty well, and it prevents things like recompilation, because recompilation can be a nightmare to address. If you have an ugly stored procedure, maybe you inherited from somebody else, you know, or maybe you wrote it, who knows? But hopefully not.
Thanks a lot, Jeff. Luke. I look at it as two different schools of thought. I think the application guys dump everything off onto the SQL Server going, and the SQL Server guys goes,
But you know, I've been to a lot of software development shops. I have yet to be in a software development shop where application development and database developer weren't the same person. I mean, I've never worked somewhere where somebody just wrote.
if you get somewhere
I've been
hardcore
to
DBA,
DBAs. Now DBAs, that's different because they're not typically writing or creating live systems with software. We've had DBAs that help optimize after the fact. But I had to create my own tables, I had to create my own relationships, I had to create my own stored procedures.
I've been encountering some where application has no access to the database. It's, I need this data. A DBA makes it and gives it to them and determines how to get it.
Yeah, that's the Obamacare website. So it's
That's right. Our pizza's 5 minutes. It is ordered.
Okay, I guess what I'll do is I'll finish up this slide, and then we'll maybe take a break.
Sure.
Or I can go as far as I can, and we'll just stop when pizza gets here.
That's fine. I mean, whatever. If anyone needs to take a break,
we're good.
finish this slide and take a break.
Okay?
Head down pizza.
And I wanted to be kind of forward thinking here. Keep your minds open to SQL Server 2014, which is now in CTP 2. That native compilation is only available for stored procs, not for ad hoc SQL. So apparently what they're doing in SQL Server 2014, which they had codenamed Hackathon, was you can actually native compile stored procedures. I know that sounds weird. It's really kind of completely foreign to the thought process of a SQL developer. Oh, pizza's here. But good stopping point. All right, questions before we eat?
So you're telling me databases are more than just data?
Yes, they're more than just data stores.
Have you pulled out 2014 yet?
I have not.
You have not.
I've been reading the blogs on it though, and it sounds pretty neat. There's some pretty cool stuff they're doing with, and this kind of surprised me that they're kind of getting away from temp tables. They're moving more towards, at least on the memory optimization side, using table variables and user-defined table types, where you can actually memory optimize those, and as long as they fit in memory, you can get huge performance gains. Okay, so we'll take a break and have some pizza. Yes.
When I had talked to them, this was quite some time ago when I was there, it was probably about 2 years ago, they told me that an 18-month development cycle